It took 7 months for the Perseverance rover to reach Mars. Wait a minute, 7 months? Imagine trying to keep people alive for that long in deep space. They need food, water, electricity, not to mention they'd be hit by a ton of radiation. But now imagine if we could get to Mars in just 3 months. What about 6 weeks? That would be a game changer for trying to get people to Mars. Nuclear propulsion might make that a reality. There are 3 types of nuclear propulsion. The first is nuclear thermal propulsion. Nuclear thermal propulsion uses the heat energy from a nuclear reactor to heat up hydrogen. This hydrogen expands and then shoots at the nozzle to generate thrust. The second type of engine is a nuclear electric and chemical engine. Now, the reactor would generate electricity that could be used to power electric thrusters, while a chemical engine could be used for its high thrust. These first 2 methods could get people to Mars in just 3 months. There is a third method though. It's called bimodal propulsion. It might just be the most promising of the 3. Bimodal propulsion works the same as nuclear electric and chemical propulsion, but instead of using a chemical engine, we're combining with a nuclear thermal engine. By combining nuclear electric and nuclear thermal propulsion, they can work off the same reactor, which is much more efficient than the other systems. This type of propulsion could get us to Mars in just 45 days. That's a little over 6 weeks. The only issue is that this technology isn't as developed as the other 2. The biggest problem with all 3 of these types of nuclear propulsion is the safety factor. If the reactor gets too hot, it could have a meltdown and potentially explode. Now, normal cooling systems aren't quite enough to make sure the reactor doesn't go into a meltdown. Now, what if I told you nanotechnology could help solve the problem of cooling? The reactor would use a fuel made of a ceramic and a metal, or called a thermit for short. The ceramic is uranium oxide, and the metal would be tungsten. This is because tungsten has the highest melting point of any metal. Nanoparticle coating technology can actually help create a thermit that's more heat resistant and corrosion resistant than ever before. Researchers use a type of nanoparticle coating technology called magnetron sputter deposition to prove that uranium oxide can be coated in tungsten to increase the melting point of the reactor fuel. A magnetron is a device that generates magnetic fields. The researchers use this magnetron to direct a ton of ions towards the tungsten metal, knocking off individual atoms. These atoms generated a metal vapor that coated a powder called yttria-stabilized zirconia. They use yttria-stabilized zirconia as a substitute for actual uranium oxide because it shares a lot of properties with uranium oxide but isn't radioactive. Usually, the coating is done on a flat surface, but coating a powder is more complex because not all the sides of the particles will be exposed to the metal vapor. This is why the researchers had to rotate the vacuum chamber as the coating was happening, to expose the covered sides of the YSZ powder and to make sure every side got coated evenly. The core shell particles had a conformal coating under 500 nanometers thick. A core shell particle is, well, exactly what it sounds like. It's a particle that has a core, which is the yttria-stabilized zirconia, and a shell, which is the tungsten. Other research has also shown that conformal coatings actually increase the density of the coating. This means that the tungsten will absorb less neutrons, meaning it won't affect the fission reactions as much, and there will be less hydrogen diffusing through the tungsten into the uranium oxide. The coating gives the fuel a much higher melting point, which means it'll need less cooling. It also makes the fuel more corrosion resistant to the liquid hydrogen that will pass through the reactor core. Now, a lot of this research has been passed over to NASA, and they'll probably be doing more tests with sputter deposition. Eventually, they'll move from YSZ powder to uranium oxide and develop a real thermit fuel that could be used in an actual nuclear reactor. We'll likely see the first tests before 2030, and hopefully we'll see a first flight during the 2030s. The biggest roadblock to getting this technology into space is getting regulatory approval from the government. If something goes wrong, and let's be honest, something probably will go wrong, NASA has to justify why they're taking the risk of using a nuclear reactor on the mission. So it's really hard for them to get actual confirmation to use reactors on a space mission. These factors make development for nuclear propulsion technology really long. Hopefully, we'll see some major strides being made soon though. If you like this video, make sure to like and subscribe. You can also check out my Twitter since I post stuff more regularly there, and my Medium where you can find the article version of this video. Thanks for watching.